problem set number 5, or the 2 problems from number 5. For the following linear system, write it in the form ax equals b. Should be a piece of cake. 1, 0, -2, 3, -7, 3, -2, 5, 0. You can see that the equation is spaced out to give you an indicator of which column your elements go into, but please make sure you're being careful so that you're putting the right numbers in the right column. Because this column corresponds to your first unknown, second unknown, third unknown, fourth unknown, equation 1, equation 2, equation 3, and equation 4. So make sure you're lining things up correctly, and here's B. Okay, write the elimination matrix E21. In order to get E21, I need the row operation to make this a 0, the 2, 1 location to be 0. So that means I would say R2 equals R2 plus 1/3, nope, wrong one, -3 R1, which means my elimination matrix, 2, 1, it's going to be the same size as A. I did not write it in the form AX equals B. I wrote the augmented matrix. Don't mess up like me. Don't lose those points. So my matrix E21 is going to be the same size. And in the 2, 1 location, I'm going to have this number, -3. So there's E21. Determine the LU factorization. No permutation, so don't do PLU factorization. Okay, so this is a 4x4, so I need to do 6 different row operations. So I'm going to go ahead and make this a 0, this is 0, this is 0. So it's going to be row 2 equals row 2 minus 3 row 1. Then row 3 equals row 3 plus 0 row 1. Row 4 equals row 4 plus 0 row 1. I'm still writing these down because I need all of these numbers, and so I'm just writing them down as a record to know how to construct L. So when I do that row operation, I get 3 minus 3, which is 0. -2 minus 0, which is -2. I'm filling 5 minus -6. I'm going to write it down on the side over here. 3 minus 3. -2 minus 0. 5 minus -6. 0 minus 9. So I get 3 or 0, -2, 11, and -9. Okay, now I go ahead and move to column 2, make this a 0 and that a 0. So row 3 equals row 3 plus row 1, or row 2, plus 1 row 2. And row 4 equals row 4 plus 0 row 2. Note, I can only use elimination. So row 1, row 2 don't change. So it's always these row operations every time. I'm just changing what this number is. And that number is going to fill my L matrix. So I have 0 plus 0, and 2 plus -2, which is 0, 4 plus 11, which is 15, -3 plus -9, which is -12, and then zeros. Or that one, row 4 doesn't change. So there we go, my last one. I need to make this a 0. So row 4 equals row 4 plus 0 row 3. There we go, so this is U. This is my U matrix. Let me just check my answers, make sure I did it right. There we go. Yep, we're good. My L matrix is going to be composed of all of my multipliers. I'm going to start with a lower triangle matrix. Which means I have zeros in the upper triangle. And then I fill in these numbers one at a time. So this one, 3, I change the sign. And then 0 and 0. Then I fill in these ones. 1, change the sign, and 0, and then fill in this one as 0. So here's my L matrix. Woo! Okay. Last thing, solve the system. This is a long problem. Solve my system. I've broken it up into LUX equals B. Erase that. Which means I'm going to go ahead and say LY equals B, and then UX equals Y. So first, LY equals B. 1, 3, 0, 0, 0, 1, negative 1, 0, 0, 0, 1, 0, 0, 0, 0, 1. Y is my unknowns. Equals my B vector, which is negative 7, 4, 11, negative 6. So this tells me y1 equals negative 7. This one tells me 3 times y1 plus y2 equals 4, or y2 equals negative 21 plus 25. This tells me that negative y2 plus y3 equals 11, or y3 equals 36. And then this one tells me that y4 equals negative 6. It's not the worst system to solve. It's just a lot of writing because it's a 4x4, so there's more numbers to write, which just makes it a lot. On your exam, you should expect 4x4s and 3x3s. We will not give you bigger than that, at least for this exam. But you should expect both. 2x2s are too small. So then I have U, X equals Y. And then I solve this system, which this one's a little bit more annoying. My last equation tells me that X4, the 4 of them, equals negative 6. 2x4 equals negative 6. Therefore, X4 is negative 3. This one tells me that 15x2 minus 12 times x4 equals 36, or that's x3. 15x3 plus 36 equals 36, or x3 equals 0. That'll make my life a little easier. So negative 2x2 plus 11 times x3 minus 9 times x4 is 25, or negative 2x2 equals, that's 27, that's 0, minus 27 equals negative 2, or x2 equals 1. I can do math. Don't we all aspire to that? x1 plus 0 times x2 plus negative 2 times x3 plus 3 times x4 equals negative 7, or x1 equals, it's negative 9, 2. If we do all our math correctly and write everything down properly, we should get that x1 equals 2. Negative 7. There we go. That's negative 9, so plus 9, yep. x1 equals 2. And there we go. I have solved my system. Once again, I can verify my system by plugging it back into my equations. Maybe I do that for one equation, maybe 2 equations. Just check to see that it's correct if I have time. Okay, the second problem is also an LU, or the second problem for problem 5 is also an LU factorization, but it also gives us L and U. Woohoo! So determine the following. Identify the 3 row operations used to factorize A. My 3 row operations come from my L matrix, where these are my multipliers. So my first one was row 2 equals row 2 minus 4 fifths row 1. Because remember, I changed the sign here. So it's positive 4 fifths, so I make it a negative 4 fifths in my row operation. Then row 3 equals row 3 minus negative 1, row 1. And then my last one was row 3 equals row 3 minus negative 23rds, row 2. So these ones make my first 2 zeros in my first column, and this one makes my 0 in my third column. Done. Solve the system equations using forward substitution and back substitution. So same idea, I have Ly equals B, yep, there we go. Lost it for a second. And then Ux equals Y. So my first one, Ly equals B. I write down my L matrix. negative 6. B2, negative 2. Finding a value for B2 such that Y2 equals 12. Okay? So this first one tells me that Y1 equals negative 6. This second one tells me that 4/5 times Y1 plus Y2, which I know is 12. Or I guess 1 times 12. Equals B2. So Y2 equals 12. Okay, so that means B2. Is B2 a fraction? B2 is a fraction, ladies and gentlemen. Negative 24 over 5 plus 12 is 65ths equals B2. B2 equals negative, no. I can do this. 60 minus 24. 36. There we go. 36/5. And then my last equation tells me that negative 1 times Y1 minus 20/3 times Y2 plus Y3 equals negative 2. Or 6. That's a 4 minus 80 plus Y3 equals negative 2. Y3 is a big number. This is negative 74 plus 74, 72. Okay, there's my Y values. Go ahead and find my U values. Or find my X values. Gosh. There we go. UX equals Y. Negative 8x3 equals 72. X3 equals, oh my gosh. There are certain multiplications that I just fail at. Some are really simple. I'm gonna do some on my calculator as well. 12 minus 12 divided by 5 times 9. The negative 9/5. Problem is my calculator's gonna be fractions. I'm sure you guys are all well versed. It's been a long time since I've used graphing calculator on a consistent basis. Although negative 9/6 should not be that difficult. Let me rewrite this. 12 times 9. Once again, I should know this. 108/5. So 12 minus 108/5. Negative 9/5 x2 equals 60 minus 108. Negative 48/5. Which means x2. Those cancel. 48 is definitely divisible by 3. I think it's 14. 16? Negative 16/3. Positive 16/3? Yes. Okay, my last equation. Gosh, it took a long time. 5 times this one up here. 5 times x1 plus 6 times 16/3 times x2 plus, I think that's a 3. Cannot write my 3s appropriately, apparently. That is a 3. Times x3 equals negative 6. 5x1 equals negative 6. This is negative 27 plus 27 minus 6 times 16 That's divisible. (16 times 2 is 32. Okay, there we go. Which means x1 is negative 11/5. And there you go. I have solved my system of equations. Don't know why we gave US fractions, but that is how I would go about solving this problem. It is an LU factorization problem. It goes over similar concepts as it was in problem A, but it's phrasing it in a slightly different way.